7 railways, 1 wall of mountains, and $300 billion. This is the staggering commitment China has made to one of the most jaw-dropping construction missions in human history. Right now, deep inside the Himalayas, the Hengduan Ranges, and the Qinling Mountains, thousands of workers are drilling, blasting, and building railways through terrain so extreme that engineers have had to rewrite the rulebook on what is even possible. Some tunnels go so deep that the rock around the workers reaches temperatures hot enough to bake bread. One section of track will sit so high up that the air has only half the oxygen you are breathing right now. And one stretch of railway took 14 years to build just 82 miles of track. For $300 billion, you could fund the entire NASA Artemis moon program more than 6 times over. You could build roughly 15 Burj Khalifas every single year for a decade. But China chose to spend it on mountains, and there is a very specific reason why. Have you ever seen a construction project this massive in your own country? Or where are you watching this video from? Please let us know in the comments below. Welcome to Expand Knowledge. It is currently May 2026, and we are witnessing the peak of a transformation that began decades ago. As we look at the progress today, we see that China has turned its focus entirely toward its rugged western frontier. For a long time, the eastern side of the country was a completely different world from the west. The coast has bullet trains connecting every major city like Shenzhen, Shanghai, and Beijing, all wired together with high-speed rail that moves people at over 200 miles per hour. Passengers board a train in the morning and arrive in a city hundreds of miles away before lunch. But as we move west toward Tibet, Xinjiang, and Yunnan, the mountains take over. Suddenly, the most connected country in the world has enormous gaps. Communities that are only a few hundred miles apart can take 2 full days to reach by road. A truck carrying goods from Western China to a neighboring country might spend an entire week just crawling through mountain passes that get snowed in, washed out, or blocked entirely. In winter, some of those roads disappear completely. This is not just an inconvenience for the people living there. It is a massive economic drain on a part of the country that holds enormous natural wealth. Underneath those massive mountain ranges sits something the global economy needs badly: coal, copper, and especially lithium. These are the materials that power everything from electric cars to smartphones. Right now, getting those resources out is slow, expensive, and unreliable. Moving a ton of lithium from a Western mine to an Eastern factory costs far more than it should, simply because the infrastructure to carry it does not exist yet. However, we must also look at the much bigger strategic picture. The world's busiest trade routes currently run through oceans and narrow sea passages that can be easily blocked or disrupted. By building enough railways through these mountains, the goal is to create trade corridors that no navy and no weather event can touch. These 7 railways are not just about moving people. They are about moving international trade, while building something far harder to disrupt than a shipping lane in open water. This is a level of infrastructure planning that seeks to rewire the very geography of the region. To understand how difficult this massive $300 billion mission truly is, we have to look at the projects one by one, starting with what engineers call the geological museum nobody asked to work in. The Sichuan-Tibet Railway costs $47.8 billion, and that nickname is definitely not a compliment. It means the ground does everything possible to stop you from building on it. The route stretches over 1,100 miles from Chengdu to Lhasa, but the real nightmare is one specific section between the cities of Ya'an and Ningxi. On this stretch, nearly 96% of the entire route is either inside a dark tunnel or on top of a massive bridge. Think about that for a moment. For almost the entire journey, the train never actually touches open ground the way you would normally picture a railway. It is either buried deep inside a mountain or hovering high above a dangerous valley floor. The elevation changes alone are staggering, climbing and dropping a combined 46,000 feet across the whole route, which is like stacking Mount Everest on top of itself over and over again. Workers inside these tunnels are dealing with temperatures over 122 degrees Fahrenheit. That is hotter than most desert storms. But the heat is not even the most dangerous part. Workers also face rock bursts, where the immense pressure inside the mountain builds up so much that the rock suddenly explodes outward, shooting sharp fragments like shrapnel in every direction. This is not a controlled demolition, it is the mountain itself pushing back against human progress. As we look at the timeline today in 2026, tunnel construction is 75% complete, with the full line targeted to open by 2030. To put this in perspective, 14 years of grueling work produced just 82 miles of completed track in the hardest sections. That is roughly the distance from Philadelphia to New York City, yet it took longer to build than some countries take to construct entire national highway networks from scratch. When this line eventually opens, it will cut the travel time between Chengdu and Lhasa from over 40 hours down to around 13. While this happens, another project carries the official title of the hardest railway ever built. The Dali-Ruili Railway in Yunnan Province is a 200-mile line that cuts directly through the Hengduan Mountains, creating a land connection between China and Myanmar. On flat ground, a standard railway takes about 3 years to build, but the first section of this line took 14 long years. The reason comes down to the Gaoli-Gongshan Tunnel, which is over 21 miles long. During construction, workers hit massive underground water flows equal to 156,000 swimming pools, essentially fighting a slow-motion flood while trying to drill a precision tunnel. If you thought the previous projects pushed the limits of what is possible, the next one takes everything to a completely different altitude. If the Sichuan-Tibet line is considered expensive, the Xinjiang-Tibet Railway makes it look like a budget project. This one comes in at $56.2 billion, and it has the most extreme operating environment of any railway ever planned anywhere on Earth. The line stretches nearly 1,240 miles from Hotan in Xinjiang all the way to Lhasa in Tibet. But what makes it unlike anything else ever attempted is the altitude. The average elevation across the entire route is over 14,700 feet above sea level. To give you a reference point, most commercial aircraft fly at around 33,000 feet. This railway sits nearly halfway to that height, and it runs there for almost the entire length of the route. At that altitude, the air has only about half the oxygen you find at sea level. Construction workers cannot simply show up and start drilling. They need supplemental oxygen just to function during a basic shift. Equipment behaves differently at these heights because engines lose power, and even simple tasks take much longer. However, the altitude is not even the biggest engineering problem. The real nightmare is permafrost. About 61% of the entire route crosses ground that behaves like solid concrete in winter and turns into soft, unstable mud in summer. The ground literally shifts between seasons, which means a track laid perfectly today could be warped, cracked, or sunken by the following year. Engineers have to design track foundations that can handle a surface that never fully stays in one position across nearly 750 miles of the route. Strategically, this railway opens up massive coal reserves and creates a permanent land corridor deep into one of the most isolated parts of the continent. Once this line is running, there will be an unbroken steel connection stretching from the industrial heartland all the way to the edge of the Tibetan Plateau. This kind of reach does not just move goods, it rewires geography. Looking at these challenges, do you think the environmental impact of building through such pristine, high-altitude terrain is worth the economic gain? What are your thoughts on building massive infrastructure over unstable permafrost? Please share your opinions in the comments below. We would love to hear what you think about these engineering risks. China is not stopping inside its own borders, as the new Silk Road is being made entirely of steel. This brings us to a massive shift in how goods move between Asia and Europe, stretching over 300 miles across 3 different countries. The China-Kyrgyzstan-Uzbekistan Railway might not roll off the tongue easily, but what it does is very simple to understand. Right now, if you want to move cargo from China to the Middle East or Europe, you have 2 main options. You either go by sea, which takes weeks and runs through narrow choke points like the Suez Canal, where a single stuck ship can hold up global trade for days, or you go by existing overland routes, which are slow, patchy, and nowhere near efficient enough for serious freight. This new railway changes that calculation entirely, cutting straight through rugged mountain terrain to create a faster path. Construction officially kicked off with a launch ceremony, and the full line runs about 325 miles, connecting Kashgar in China to Andijan in Uzbekistan. About 40% of the entire route is made up of bridges and tunnels, including 50 bridges and 29 tunnels that together cover 75 miles of the most difficult sections. The cost comes in at $4.7 billion, and China is providing half of that as a 35-year loan, while holding 51% ownership of the joint venture. For Kyrgyzstan and Uzbekistan, this is critical infrastructure they could not fund alone. But for China, it is a direct investment in a faster path to global markets. The payoff is enormous for everyone involved because once this line is running, transit time drops by 7 to 8 days compared to current overland and sea routes. 7 to 8 days might not sound dramatic until you realize that global shipping runs on extremely tight margins. Cutting a week off transit time means fresher produce arriving at markets, lower logistics costs passed on to buyers, and faster turnaround on everything from electronics to raw materials. This is the new Silk Road. But instead of camel caravans crossing sand dunes, it is freight trains crossing mountain passes at high speed. The ancient trade route between East and West is being rebuilt in steel. And while the destination remains the same, the method of travel has changed completely for the modern global economy. While all of this is happening across Central Asia, one more project could shift the balance of trade in South Asia, covering a stretch of proposed railway that might be the most geopolitically significant piece of track in the entire $300 billion program. The proposed China-Nepal Railway would connect the Tibetan border directly to Kathmandu, Nepal's capital city. An incredible 98.5% of this route would consist of bridges and tunnels, which tells you everything you need to know about what this punishing terrain looks like. The estimated cost is $8 billion for the full line, and a comprehensive feasibility study is currently due this month, in June of 2026, to determine exactly how construction will move forward. Nepal has been pushing hard for this connection because a past trade blockade cut off its supply of fuel and medicine, exposing just how vulnerable a landlocked country becomes when it depends entirely on a single trade route. A northern rail link through Tibet changes that equation completely by giving Nepal a second door. For a small country sitting between two of the world's largest economies, having two independent trade routes instead of just one is the difference between managing a crisis and being completely paralyzed by one. For China, the payoff is a permanent, all-weather land connection into South Asia, a gateway that no weather event and no sea-based disruption can shut down. If this line gets built, it becomes the first physical rail link between China and the Indian subcontinent, changing the trade dynamics of the entire region for decades to come. When we look at the timeline for all 7 railways, the dates are closer than most people realize. By the end of 2026, the Xi'an to Wuhan high-speed line is set to open, cutting travel time from 5 hours down to 2.5, with trains moving at 217 miles per hour through mountains. By 2030, the Sichuan-Tibet Railway and the China-Kyrgyzstan-Uzbekistan line are both set to go live, creating a near-complete rail loop around Tibet's borders for the first time in history. Further out into the 2030s, the Xinjiang-Tibet line and the Nepal route will complete a land-based network that connects China to Central Asia, South Asia, and eventually Europe through an unbroken chain of steel. $300 billion, 7 railways, and mountains that push temperatures and altitudes to absolute extremes. The mountains did not move, but a way through them has been engineered. As we close this analysis, which of these 7 mountain railways do you think will have the greatest impact on global trade? Do you believe land-based rail networks can truly replace traditional ocean shipping lanes in the future? Also, we would love to know, where are you watching this video from today? Please drop your city or country in the comments below and share your thoughts with us.